Hi. For our machine learning project, we selected a dataset from Kaggle. So now we are going to predicting whether a patient has chronic kidney disease or not using the medical data. Since this is a classification problem, we are using supervised learning, and I am Pereira MIS, and I implemented the logistic regression model. So first, I import all the libraries that are going to use, and then I load the dataset, and then this is for the basic data inspection for whether there's missing values. And then in here, I drop the unnecessary ID column to start to select in order to select the features. So it displays as I have selected 24 features. And then in here, uh, I am start the data pre-processing part. So it replaces all the symbols with the proper NaN values. And here uh, I use uh, I convert categorical variables into numbers using label encoder and map the target variable to 0 and 1. So this is where I use the label encoder. In the 7 cells, I define the x and y axis in order to visualize the data set. So the x-axis going as the features and the y-axis shows the diagnosis. So next cell, uh, so this is basically for the data visualization. So this is the bar graph, and these are the key features distribution uh, by class. And then I'm going to split the data set in order to avoid the data leakage. So and in here uh, I apply imputation and scaling only on training data to prevent the data leakage. So this is where I simple this is where I use simple imputer for that. So and then uh, I trained the logistic regression model and evaluated it using a five-fold cross-validation. So these are the outcome of that. And after that, I generate predictions and compare them with the actual values. So basically, this is the classification report, and this is the confusion matrix. And I plot the ROC curve to evaluate the model performance across all threshold value. And this is the feature importance, uh, top 10 most important features. And then this is the results summary, and I print a final summary including accuracy, ROC curve, and confusion matrix values.
Hello, I'm Piyusharan Singh and I have done the decision tree algorithm. So first, in the first cell, I have imported required libraries for the data handling, visualization and machine learning. And pandas and numpy are used for data processing, matplotlib and seaborn for visualization, and scikit-learn for building the decision tree model. So when loading the dataset, I have loaded the chronic kidney disease dataset using pandas and explored its shape, columns and missing values. So this is the outcome of it. And next, I clean the data set by handling missing values, converting data types, and encoding categorical variables using this. And finally, I have used mean imputation to fill missing values. And next, I have visualized the data using class distribution and correlation heap map and feature distributions. to understand patterns and relationships. So this is the class distribution graph, and this is the feature correlation heat map, and this is the feature distribution by class. So next, I have split the dataset into training and testing sets to evaluate model performance. And next, I have trained a default decision tree model and evaluated it using accuracy, ROC, AUC, and classification matrix. So this is the outcome of it, the default decision tree and the classification report. So next, I have used the grid search CV to optimize the model by turning parameters such as tree depth and splitting criteria. And next, I have tuned model improved performance and the tuned model improved performance and achieved better accuracy, precision, recall, and F1 score. This is the classification report. You can see the results of it. And next, I have visualized model performance using confusion matrix, ROC curve, and feature importance. So these are the graphs of the confusion matrix, ROC curve, and feature importance. And next, I have visualized the decision tree structure to understand how predictions are made. So this is the decision tree structure. And next, I have used the tenfold cross validation to ensure the model is reliable and not overfit. And also, finally, I have compared the default and tuned model, showing improvements in performance metrics.
This project uses the random forest classifier to predict whether a patient have chronic kidney disease or not. And here I'm importing the libraries that we are using, pandas and numpy for data handling, and matplotlib and seaborn for charts, and several sklearn tools, and also here grid search CV for hyperparameter tuning. And here I'm loading the dataset into the notebook, and then I have inspect the dataset. Here, as you can see, these are the null value count, and we have 248 CKD and 150 not CKD patients, and I have represented that using a bar chart here, class distribution of the of our dataset. So here I have visualized the missing values in charts, and which these charts are showing as a count and a percentage, and I have represented it in a bar chart here. And then here I am doing the data pre-processing, which I have dropped the ID column, which we do not need for our classification and prediction process, and I have replaced this placeholder with NAN, and also converted the text based numbers to actual numbers, and also clean the encoding target column. Here clean the encoding target column, and also encoded the categorical features like RBC, PCC, and like those two zeros and ones. So as you can see here, we have a missing value count, and then here I'm separating the features which are 24 which are our 24 input features into X, and our target variable, which is classification, into Y. So, and then I'm doing the train test split, which I'm using 80% of the data on training, which is 320, and then for testing I'm using 20% of the data, which is about 80 data, and I'm doing this while preserving the class proportion. Here I'm doing the mean imputation for replace the missing values, So after doing the mean imputation, we do not have any missing values in the training set or the testing data set. The mean imputation means that I'm replacing the missing values with the average of that column. So here I'm training the random forest on 100 trees. So here I'm achieving 100% accuracy for that training on my testing data. And here I'm doing hyperparameter tuning with the grid search CV. As we can see here, it gives us the best parameters that I have found. The best number of trees are 200, and for the best accuracy we are getting 99.69 for cross validation accuracy. This is with 5-fold cross validation. And then I'm evaluating the tuned model, which we are again achieving 100% evaluation, 100% accuracy. And for the true positive count, we are getting 50, and the true negative count we are getting 30 on our testing data set. As you can see here, our class distribution is 50 and 30. And then I'm comparing the confusion matrix for default random forest and the tuned random forest. Both are perfect. 30 for negatives and true negatives, 30 for true negatives, and 50 for true positives in both. And then I'm doing 10-fold cross validation on the entire data set. The mean accuracy that I'm getting is 99.5, and out of all 10 cross validations, I'm achieving 100 for 8, which this confirms the model is strong and not just lucky on one split. And here for the final comparison table, the summary table, it shows both models achieving identical perfect scores on the testing set. The tuning process validates the models.
Let me demonstrate the k-nearest neighbors algorithm. In here, first you can see we importing libraries and setup. Then we load the dataset using pandas and check its structure using shape, head and info. Then we fix column names and replace wrong values like missing values. Then we convert columns into correct data types and check how the target variable is distributed. Then we convert the target column into numbers. Then we separate features into numerical and categorical types. In here we build pipeline to prepare the dataset. Numerical dataset is cleaned and scaled, while categorical dataset is converted using one-hot encoding. In here, we split the dataset into training and testing set while keeping the class balance. Then we apply preprocessing to both sets properly to avoid data leakage. In here, we use Smart to balance the classes in the training data. This helps the model learn better and reduces bias. Then we use grid search CV with stratified k-fold to test different models. This is the summary of Smart Balance training data. Then we do best model based on ROC and AUC score. Then we take that optimized KNN model to final use. You can see the output in here. Then we do model evaluation. In here we do prediction. You can see we import all the matrices in here, then calculate comprehensive evaluation matrices, get confusion matrix, calculate sensitive specific, KNN specific analysis. You can see all that in here. Then we get confusion matrix visualization. Then ROC curve visualization. Then we compute model matrices. Then we do k-value performance analysis, KNN specific visualization. Then we do industry level advanced analysis and insights like cross validation stability analysis, data imbalance impact analysis. Likewise, let me show you the output. Then we have executive summary dashboard.